In the beginning, God created the heavens and the earth. Now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And God said, "Let there be light." And there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening and there was morning, the first day. And God said, "Let there be a vault between the waters to separate water from water." So God made the vault and separated the water under the vault from the water above it, and it was so. God called the vault sky, and there was evening and there was morning, the second day. And God said, "Let the water under the sky be gathered to one place, and let dry ground appear." And it was so. God called the dry ground land, and the gathered waters he called seas. And God saw that it was good. Then God said, "Let the land produce vegetation, seed-bearing plants, and trees on the land that bear fruit with seed in it, according to their various kinds." And it was so. The land produced vegetation, plants bearing seed according to their kinds, and trees bearing fruit with seed in it according to their kinds. And God saw that it was good. And there was evening and there was morning, the third day. And God said, "Let there be lights in the vault of the sky, to separate the day from the night, and let them serve as signs to mark sacred times and days and years. And let them be lights in the vault of the sky to give light on the earth." And it was so. God made two great lights, the greater light to govern the day, and the lesser light to govern the night. He also made the stars. God set them in the vault of the sky to give light on the earth, to govern the day and the night, and to separate light from darkness. And God saw that it was good. And there was evening, and there was morning, the fourth day.
The heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard. Their line is gone out through all the earth, and their words to the end of the world. In them hath he set a tabernacle for the sun, which is as a bridegroom coming out of his chamber, and rejoiceth as a strong man to run a race. His going forth is from the end of the heaven, and his circuit unto the ends of it, and there is nothing hid from the heat thereof. The law of the Lord is perfect, converting the soul. The testimony of the Lord is sure, making wise the simple. The statutes of the Lord are right, rejoicing the heart. The commandment of the Lord is pure, enlightening the eyes. The fear of the Lord is clean, enduring forever. The judgments of the Lord are true and righteous altogether. More to be desired are they than gold, yea, than much fine gold, sweeter also than honey and the honeycomb. Moreover by them is thy servant warned, and in keeping of them there is great reward. Who can understand his errors? Cleanse thou me from secret faults. Keep back thy servant also from presumptuous sins. Let them not have dominion over me. Then shall I be upright, and I shall be innocent from the great transgression. Let the words of my mouth and the meditation of my heart be acceptable in thy sight, O Lord, my strength and my Redeemer.
Space, the final frontier.
These are the voyages of the Parish Church St. James.
Its mission action plan, to explore the solar system and the galaxies.
To seek out open shops that sell flour and tea.
To boldly go where no church has gone before.
second stage tanks now pressurized. 35 seconds and counting. We are still go 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Beyond the rim of the starlight, my love, he wanders in starflight. I know he'll find in star-clustered regions love, strange love, a star woman teaches. I know his journey ends never. His Star Trek will go on forever. But tell him while he wanders his starry sea, remember, remember me. I know his journey ends never. His Star Trek will go on forever. But tell him while he wanders his starry sea, remember, remember me.
If you're the sort of person who believes the universe is by chance, it's just an accident, it's probably easier to believe that if you don't know much about it. The more you know about the universe, the more you recognize it as the handiwork of God. It is beautiful. It's not an accident. It is stunning artwork, and we're going to see some of those this evening. And then, of course, it's immensely big. God made a universe that is just beyond our ability to comprehend. I'm an astrophysicist. I can't comprehend the size of the universe. I can give numbers in terms of how far we've been able to probe so far, but even those numbers, we use exponential notation and so on because you can't really grasp it. But nonetheless, I can build up certain things and compare them to other things and give you kind of a feel for just how amazing this creation is that the Lord has placed us in. We're going to start with the moon. The moon has its own beauty to it. It's one of the astronauts who walked on its surface called it a magnificent desolation, and it is. It's got a beauty to it, but it's a desolate kind of beauty. It doesn't have the the features that Earth has, but it is beautiful, and it's fun to look at through a small telescope, backyard telescope. This is a mosaic image of the moon where they've taken lots of very high-resolution images and stitched them together, and sometimes the brightness doesn't quite match. That's why that's the case. This was taken with the Lunar Reconnaissance Orbiter. We have a spacecraft orbiting the moon and taking very high-resolution images of the surface. And I love looking at the moon through a small telescope. I love showing it to others through a small telescope because they look at it and they say, wow, that's impressive. It has a beauty to it. And then sometimes they'll ask, well, Dr. Lau, can you see the flag that the astronauts planted? Well, no. The moon's about the size of the United States, so you're not going to see something that small on its surface when you consider how big it is. Again, smaller than the Earth, though, and 240,000 miles away. I mean, that's pretty far, but we can kind of get a grasp of that. Some of you might have a car that has 240,000 miles on it, if you got a really good one, right? And so you theoretically, you could have driven that distance over a long period of time. You could have made it. The astronauts, they were traveling at the speed of a bullet, and they took 3 days to get there, just to give you a feel for it. Now, we can't see the flag, but it's interesting. Because of that Lunar Reconnaissance Orbiter, it's so high resolution, it actually can see the places where the astronauts landed. And so if we zoom in here on Mare Tranquillitatis, which is where the Apollo 11 spacecraft landed, we can see what's left of the lander there. Isn't that fascinating? And remember when the astronauts landed using the LEM, the Lunar Excavation Module, that spider-like looking structure, they left the bottom of it and just launched the top portion to save fuel. And so the bottom portion's still there. And you can see the lunar module right there and some equipment that they left on the surface. And that dark streak going over from the lunar module over to that crater, that's the footprints of the astronauts. And so it's kind of interesting. They're 40-year-old footprints, and they're not going anywhere. The moon is rather dusty, and it doesn't get any maid service, so they're gonna remain there for a very long time. There's no weather on the moon, there's no wind or anything, so footprints stay footprints for a long time. So that's absolutely amazing, I think, that we can see that sort of thing. The scale of the cosmos is as amazing as its beauty. So here's the moon, and let's compare it in size to the Earth. There you go. So you say, well, yeah, we got the long end of the stick on that one. Pretty big. Earth's pretty big, and it is, until you compare it to something like Saturn. Saturn's 9 Earths across. That's just the planet. The rings extend out even further into space. The rings are trillions of tiny little moonlets that orbit around Saturn. You say, wow, Saturn's pretty amazing. It's pretty big, and it is, until you compare it to the sun. The sun is 100 Earths across, and it's basically a stable hydrogen bomb, a very efficient power source, fusing hydrogen into helium that releases an enormous amount of energy. The sun gives off more energy in 1 second than 1 billion major cities could use in an entire year. And if that seems wasteful, you need to remember God has unlimited power. And of course, the sun is just one star. Yes, those little tiny pinpricks you see in the night sky, those are the same type of objects as the sun is. The sun is a star. It's a main sequence star. Main sequence means that it obeys a rule that if you know the mass of the star, you basically know everything else about it. You know how big it is, how hot it is, how bright it is, the surface color, which is determined by temperature. And the sun obeys that rule, and most stars do, and then there are some that are unusual. They're a little bigger, like giants and supergiants. Main sequence stars that are less massive than the sun are smaller and redder. They're called red dwarf stars, and they're very numerous. They're all over the universe, but you don't see them very easily because they're not very bright. They don't show up very well. Some of the stars that are more impressive, though, are quite a bit bigger than the sun, like Mintaka. This is one of the stars of Orion's belt that you see in the winter skies. And so again, just keep in mind the scale of things. So we got the Earth. The Earth's 1/100th the width of the sun. You could line up 100 Earths across the sun. And this star, you can see, it's quite a bit bigger than the sun, isn't it? You could line up a number of suns across its surface. But there are stars bigger than Mintaka, like Canopus, for example, which you probably can't see that from Nebraska. You'd have to travel a little ways south because it's close to the Earth's, it's in the southern hemisphere sky. But you can see it's a white supergiant. Look how tiny the sun is compared to Canopus. It's remarkable. And there are stars bigger than Canopus, like, for example, Antares. Yeah, pretty amazing. You could line up 600 suns across Antares. Amazing. And 100 suns, or 100 Earths across the suns. You multiply that out, and Antares is really big, really big. And of course, there are things bigger than that, but that's about as big as stars get. But stars come in clusters sometimes. Some stars are kind of single, like the sun. Some come in binary pairs or triple pairs. And then some, you have these massive clusters there's probably 100,000 stars in that cluster. Isn't that beautiful? And by the way, you can see these in a backyard telescope. You just got to know where to look. And they're all over the summer sky. It's really quite stunning. It reminds me of the passage that we just heard just a few minutes ago, that God calls them all by their names. God has a name for each one of those stars. Isn't that amazing? 100, and we can't even count that many. We think there's maybe 100,000 there, but we can't. It's not like anybody sat and counted them. We just estimated it. So fun to look at, beautiful. Some of my favorite objects, though, in the universe are not stars at all. They're nebulae. From the Latin meaning cloud. A nebula is a cloud, not of water vapor like an Earth's atmosphere, but a cloud of hydrogen and helium gas. That's the same stuff stars are made of. They're made of hydrogen and helium gas, but the gravity of a star keeps it in a spherical shape, whereas the nebula is so spread out, the gravity's minuscule. And so if you have stars nearby, they'll heat up that gas and cause it to glow, and you get the most beautiful and vivid colors in some of these things. They're wonderful to photograph. You can see a lot of these with the small telescope, although you really can't bring out the color because at night you're using primarily your rods, which are not color sensitive. So it looks kind of like a grayscale version of that, but it's still beautiful. And so when you get those stars nearby, it'll heat up the gas, make it glow. Sometimes it'll reflect off the gas, you get a reflection nebula. Sometimes you get a star cluster and a nebula right next to each other. There's a star cluster down there. And so that's always a neat thing when that happens, when they're lined up that way. But the point is, this thing is huge, and to the point that our solar system wouldn't really show up on this image. It's that big. Some nebulae are enormous. Some are relatively small. They're only about the size of the solar system. It's about as small as they get. And these are called planetary nebulae. Some of them are round and look like an out-of-focus planet. And so here you have a planetary nebula. There's a star in the middle. In all planetary nebulae, there's a star in the middle, and it's ejecting gas. And sometimes they have kind of a two-lobe structure. We think the star is ejecting gas along the axis of the poles, the north and south pole of the star, because it's spinning. And so this is dynamic. It's not only artwork of God, it changes over time a little bit over the centuries as these gas clouds expand away from that central star. All kinds of planetary nebulae out there. Some of them are bipolar, some of them are round. And it could be the ones that are round are also bipolar, but maybe we're looking right down the barrel. That's a possibility. We don't know because we can't get another angle on it. So there's still a lot of surprises left for us in the universe. One of my favorites is the Ring Nebula. And it does look kind of like a ring. And it's one of the first that I learned how to find. You can see this in a small backyard telescope not too far away from the star Vega on a clear summer night. And it looks just like that, or rather a grayscale version of that. It looks like a little glowing smoke ring, and it's so strange because, most places you point a telescope, you see stars and stars and stars, and they're beautiful, but they're stars. There's one little magic spot where you will see a glowing smoke ring, and it's so strange to see this little cosmic Cheerio suspended on nothing there in space, just hanging there. You're expecting it to expand like smoke does on the Earth, and of course it is expanding. It's just enormous, and so you don't notice the expansion unless over maybe centuries you would. So there's the little stars in the middle. The star has collapsed in on itself. It's a white dwarf now. It's no longer fusing hydrogen. So all of these structures that we've looked at, these planets and stars and nebulae and star clusters, are part of a much larger structure, which we call a galaxy. And so a galaxy looks something like that. And so we live in a structure something like that, about 2/3 of the way out. Our galaxy is similar to this in that it's spiral, it's disc-shaped, and we live in between a couple of the spiral arms there. Stunningly beautiful. So what you're seeing here is a collection of about 100 billion stars. So many that it's hard to pick out any individual star. And it wasn't until the 20th century that people realized what these were. We could see them even in the 1700s. You could see these structures, but they thought maybe they were nebulae, clouds of gas, because they couldn't see individual stars. And then finally, in the early 20th century, the technology had developed to the point where we could see individual stars for the first time in these galaxies, and that proved that they are in fact very far away, much farther than we had realized. And suddenly, we realized the universe is much bigger than we previously thought, because there's not just one galaxy out there. There are billions, hundreds of billions, in fact. There are all kinds of galaxies. Galaxies of tremendous beauty. There are galaxies of tremendous ugliness. Yeah. There are galaxies that have large, mysterious arrows next to them. You'll find that in all the textbooks. There are galaxies that have rings of stars surrounding them. There are galaxies that look like flying saucers. That is a real galaxy. That's the Sombrero. You can see that in a small telescope. That's part of the Virgo supercluster, visible in the spring sky if you know where to look. And you can even see that dark dust lane in front of it, because galaxies have not only stars, but they have gas and dust. And the dust tends to be focused along the equator if it's a spiral galaxy. And that's what you see. Isn't that lovely? Absolutely beautiful. There are galaxies in the process of collision. That's interesting. And people say, is that a problem? Galaxies colliding like that? Not for us. Actually, the stars would all miss each other because the stars are tiny compared to the distance between them. It'd be like, throwing a sand grain at another sand grain and hoping they collide. It'd be almost impossible. The stars will pass harmlessly past each other. Here we have a cluster of galaxies. So every one of those little fuzzy spots you see there, that's not a star. That's a galaxy with perhaps 100 billion stars each. Isn't that amazing? And that's just one little section of the sky. We pointed the Hubble Space Telescope at a relatively empty region of the sky, a region we thought was relatively empty, and did a time exposure image of it, and we found that out at these tremendous distances are galaxies upon galaxies upon galaxies upon galaxies. Every one of those little things that you see there is a galaxy. Even the ones that are just tiny, they're just at tremendous distances from us. And so each one of those things might have 100 billion stars in it. And you extrapolate that and you figure, well, if that's typical, then that means the visible universe has probably at least 100 billion galaxies, one for every star in our own. And so that's amazing. And if you think about that, all of that was spoken into existence by the Creator, by God. He spoke and they stood fast. That's power right there. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, He made the stars also. God has a delightful sense of humor. And astronomy is quite a lesson in perspective, because Genesis, we read the Genesis account because it's written for us, it's written for human beings. It focuses primarily on the earth, but it does tell us that on day 4, God made everything else. God spends 5 of the creation days working the earth, making it right for life, for those creatures that He made in His own image. He takes one day, day 4, and says, you know what would go really good with an earth? How about 100 billion galaxies? And He speaks those into existence too. And again, people say, why would He make it so big? Why would He make all those hundreds of billions of galaxies? They're probably not necessary for life. But then again, God has unlimited power. And if that's what He's trying to demonstrate here, He's succeeded. Think about the energy of all those stars. Remember, the sun gives off more energy in a second than 1 billion cities could use in a year. And there's hundreds of billions of stars just in our galaxy and hundreds of billions of galaxies. That's a lot of energy, isn't it? You can't wrap your mind around that. You can just say, wow, praise God. So the Bible is right when it says that the universe declares God's glory. The universe is not an accident. It's a wonderfully designed piece of art, really, that's functional.
On your last trip, did you discover what the Earth people eat? They eat a great many of these. They peel them with their metal knives, boil them for 20 of their minutes. Then they smash them all to bits. They are clearly a most primitive people.
For mash, get smash.
It's very odd. I don't even know your name, but after this one Camparian soda, I feel I almost know you. May I freshen your glass? Soda, of course.
No, lemonade.
Camparian lemonade.
Yes, nice colour, isn't it?
Campari, with soda, with lemonade, with tonic, but always with pleasure.
Were you truly wafted here from paradise?
No, Luton Airport.
5, 4, 3, 2, 1. Kellogg's Sugar Smacks are go. Plenty of Thunderbird's energy fast when you need it. The Thunderbirds team all have Sugar Smacks for breakfast.
You'll love these honey sweet puffs of wheat.
Don't be left behind. Kellogg's Sugar Smacks are go. FAB.
Come on, come on, come on, move, move, move. These aren't just any old bubbles getting into this bottle of Corona. No, sir. Are they fizzy? Everyone has passed the Corona physical. Nice. Boy, it's really tough back there. No, no, no.
Corona. Every bubble's passed its physical.
That's it, boys. Let's see you fizz, fizz, fizz.
Mount Sharp. NASA now has a big challenge to find a way to get Curiosity up the mountain. Using data from orbiting spacecraft and combining it with pictures from Curiosity, the team puts together a 3D map of the terrain. Each path up Mount Sharp is risky, but scientists finally agree on a route. This path will take Curiosity past some sites of interest on its way up. First stop, Yellowknife Bay. The area here looks to be made up of sedimentary deposits. The science team concludes that this crater was once home to a large amount of water. This is Curiosity's first major finding. Curiosity now turns its focus towards Mount Sharp, beginning its 2-year-long journey towards the Pahrump Hills at the mountain's base. Passing a site named the Kimberley Formation, Curiosity stops to take some pictures. Again, the sediments found here confirm the crater was once a watery place. Curiosity also passed a site named Garden City, an outcrop with huge mineral veins winding across the surface. Curiosity studied these veins, sending valuable data back to Earth for geologists to scrutinize. Curiosity stops to take a picture of the Martian sunset, which is actually blue on Mars, unlike the red sunsets we see here on Earth. Scientists believe this is due to the fine particles in Mars' atmosphere, which permit more blue light than here on Earth. This image of what is known as Whale Rock shows an example of cross-bedding. That results from water passing over a loose bed of sediment. As Curiosity says goodbye to the Pahrump Hills, it heads towards one of the most interesting regions so far, the Bagnall Dunes. This dune, named Namib Dune, stands at about 13 feet. The Bagnall Dunes were the first dunes ever to be examined up close on another world. NASA took great care when crossing the dunes as to avoid the fate of another previous rover, Spirit, which became trapped in a sand dune during its journey. The chosen path up Mount Sharp will take Curiosity out of the Bagnall Dunes, crossing through the Naukluft Plateau into a territory called Murray Buttes, before traversing back into the Bagnall Dunes. Naukluft Plateau, the entrance to Murray Buttes, is marked by 2 tall sediment structures, which Curiosity will have to pass through. This image was also taken on the 4th anniversary of Curiosity's landing, or its 4th birthday. The team at NASA had Curiosity sing Happy Birthday to itself. Curiosity studied these structures up close while passing. This one, named the Stimson Formation, is an ancient remnant of eroded sandstone that originated when winds deposited sands, after lower Mount Sharp had formed. This layering within the sandstone is called crossbedding, and indicates that the sandstone was deposited by wind as sand dunes migrated. as Curiosity waves goodbye to Murray Buttes and continues the long journey up Mount Sharp, it comes across an interesting hill named Ireson Hill. Standing at about 16 feet, this alien-looking hill provides a great view from Mars. Crossing over more sand dunes, Curiosity comes across a region known as Ogunquit Beach. The large crests present on the dunes, combined with the smaller ripples, are not seen anywhere on Earth, making these dunes the strangest ever studied. The determined rover now heads towards its highest point yet, a ridge known as Vera Rubin Ridge. The repeated beds on the rocks indicate progressive accumulation of sediments that now make up the lower part of Mount Sharp, although from this distance it is not possible to know if they were formed by aqueous or wind-blown processes. Curiosity will have to get closer. As Curiosity climbs Vera Rubin Ridge, scientists determined that the structures here were formed due to wind erosion, and by being more resistant to the erosion than the rocks surrounding the ridge, some strange formations have been created. As Curiosity reaches the top of the ridge, the view is incredible. It shows the rover's journey so far from where we started in the Gale Crater. In the distance is the northern rim of the Gale Crater, with Mount Sharp standing at 5 miles high behind Curiosity. In June 2018, however, a global-scale dust storm hits Mars and damages Curiosity's fellow rover Opportunity, which is exploring a different region of Mars far, far away. This image shows the difference in the sky over just 3 days from Curiosity's perspective, in one of the least affected regions of the dust storm. As the storm subsides, Curiosity turns to look uphill at Mount Sharp and spots a region of clay, which could give more clues about how water helped to shape this area. Curiosity takes a selfie at a site known as Glen Etive. This is done using the camera on the rover's robotic arm. 57 individual images are then stitched together, and the arm is digitally removed from the final image, providing a perfect view of Curiosity. As Curiosity traverses the clay-bearing unit, it comes across a site named Teal Ridge. The samples that Curiosity took in the clay-bearing unit have proved to contain the most amount of clay ever found on Mars, which signals a strong presence of water in the ancient past. At the time of making this video, Curiosity is still climbing Mount Sharp, now heading towards an area known as Western Butte. Curiosity's journey is still ongoing as of 2020, but it's not the only story of exploration on Mars. Curiosity's older sibling Opportunity stopped contacting NASA in 2018 after sending one last spooky message. The last message NASA received from Opportunity was, "My battery is low and it's getting dark."
heart is still a fireball. A fireball. Every time I gaze into your starry eyes. Fireball. Fireball. Every time I gaze into your starry eyes. Fireball.
Zoom! It's Zoom, the new ice space lolly with 3 fruit flavor stages. And there's a space picture card with every Zoom. Get your Zoom now.